Hello everyone, we would like to present our hydrology group project. Let's start.
The introduction: Water is the essential element for all life on Earth. Malaysia's primary sources of water are lake, river, and groundwater. The absence of water would mean that life cannot exist. Due to the profound effect of globalization on nutrient, precipitation, also known as a rainfall, is the primary source of water for any given area. Too much or too little rain will result in drop of and floods. Because of the challenges associated with hydrology and cycling, managing the water qualities in urban has become increasingly important. Malaysia is the one of the country that receive a lot of precipitation year-round, so water management is essential to maintaining the stability of the water cycle. The relationship between rainfall and flood. The relationship between the likelihood of flooding and rainfall is crucial. The design storm technique is the widely used method in engineering practice that estimate the hydrograph by using a rainfall runoff model from a simulated rainstorm with the same chance with a given peak discharge probability. The rational formula is another often used method for translating rainfall to flood probability. It calculates peak stream flow from a critical rainfall intensity. A fascinating theoretical problem is a relationship between catchment dynamics, which create the flow frequency curve, and statistical feature or extreme rainfall. Introduction: Catchment area is a watershed is an area of land surrounded by hills where water collect after a rainstorm. Water flow down hills and collect in the river and stream at this location. These zones are important for assessing geographic region as they attempt to understand regional cascade and flows. This is important lens through which to examine the site as water movement affect much of the landscape, vegetation and ecosystem. This can support watershed formation and water level. This is the same idea underlying watershed analysis as boundary between watershed. The watershed is a natural boundary that runs parallel to the highest peak of an area. The watershed area is divided into sub-watershed area along contour line. For the background of study, this project used the official portal of the Department of Irrigation and Drainage Ministry of Environment and Water Malaysia as a source of information and data on flood in Malaysia. The mission of the Division of Water Resources Management and Hydrology is to manage the world-class national hydrology network and provide high-quality data for operational hydrology, water resource assessment, and research. Its tasks include the collection and processing of hydrological data for the purpose of developing and managing current and future water resources. The objective for this project: first, to investigate the rainfall and water level at selected station and river. Second, to determine and display the standard hydrographic map for the selected station and river. Third, to determine peak flow of the selected river.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Ali Faikal and I will present about for our project for part methodology. So for this project, the Irrigation and Drainage Department, we use the official web of Public Info Banjir to find the station. So this website, their main objective is to provide engineering service beyond the capabilities of the target group and feature ensure land use and more efficient management of countries' water resources. We can obtain the data from Public Info Banjir and find the location of our station on a map provided on the website. The second software that we use for this project is Google Earth Pro. Google Earth Pro is a computer software that uses satellite photography to create three-dimensional image from Earth. The program creates a map of Earth by overlaying satellite photos 4,444 aerial photo and GIS data onto his 3D globe, allowing users to see 4,444 cities and landscape from multiple perspectives. User can explore the Earth by entering address and coordinates using keyboard or mouse. The three methods that we use to collecting the data is arithmetic mean method, isoyetel method, and the third one is Tyson polygon method. For the first method is arithmetic mean method. Arithmetic mean method technically calculate area precipitation using the arithmetic mean of all point or aerial measurement considered in the analysis, and that is the formula for this method. And the second method is Tyson polygon method. Another for calculation average precipitation is the Tyson method. This technique has the advantage of being quick to apply for multiple storm because it uses fixed sub area. And the last method that we use is isoyetel method. This method based on the interpolation between measuring device. The produce consists of recording the amount of rainfall data and plotting the location of rain gauge on map. Interpolation is formed between measuring device to display rainfall in stage. So as you can see, this is the hydrograph and hydrograph by the station. For the first station is Sungai Labis Kampung Gatong. The second station is Empangan Jause. And the last station for our project is Station 3 LPP Labis.
For data presentation, my group already chose the state in Johor Bahru and the district is in Segamat. So, rainfall data. So, my group got 3 stations from Segamat, which is rainfall data in station Sungai Labis in Kampung Gatom, rainfall data in station Empangan Juaseh, and also rainfall data in station LPP Labis. Next, for water level data. For water level data, my group got the data from station Sungai Labis Kampung Gatom. So first, rainfall data in station Sungai Labis in Kampung Gatom. So we got the rainfall data from 3 different months, which is 21 January until 27 January. Next, 16 April until 22 April. And lastly, 17 December until 23 December. So the highest rainfall data in January 2023 is in 24 January, which is the rainfall data is 210 mm. For the April, the highest data for rainfall is 17 April. And for December, the highest rainfall data is 23 December. So number 2 is rainfall data in station Empangan Juaseh. My group choose the same month for this station. So the highest rainfall data in January in station Empangan Juaseh is in 24 January, which is 344 mm. For April is 16 and 17 April, which is 44 mm. And for December is 18 December, which is 8 mm. So for the last rainfall data is in station LPP Labis. So the highest rainfall data in January is in 24, which is the rainfall data is 77 mm. And April is in 17, which is 70 mm. And lastly in December is in 19, which is 3 mm. So next is water level data in station Sungai Labis Kampung Gatom. So for this water level data, we choose from 3 different months, which is January, July, and November. So the highest water level data in January is 25, which is the data is 40.10 meter. Next, in July, the highest water level data is in 7 July, which is the data is 37.60. And lastly, in November is in 2 November, and the data is 38.74 meter.
Now, I would like to present the analysis and result. First, we use the arithmetic mean method to find the precipitation. We collect the total daily rainfall for Sungai Labis di Kampung Gatom, Empangan Juaseh, LPP Labis for the total precipitation. Then, we find the average precipitation as these 3 stations. After that, we use these 3 answers to substitute into the arithmetic mean method formula. Finally, we find the precipitation is 9.19 mm. The second method is thesis polygon method. First of all, we find the catchment area by using Google Earth Pro. We found that A1 is equal to 8 km square, A2 equal to 24.7 km square, and A3 is equal to 21.6 km square. The total area is equal to 54.3 km square. Then, the area is multiplied with total precipitation. The total is equal to 580.4 km square mm. Then we substitute this all value into the thesis polygon formula. We found that the precipitation is 10.69 mm. For the isolator method, first we find the average precipitation and the area. Then area is multiplied with the average precipitation. We found that 511.47 is the total. Then it's divided with the total area, which is 54.3. The precipitation is equal to 9.42 mm. For the second part of this project, we generate hydrograph. We choose a method which is straight line method to separate natural hydrograph into 2 components. By using Q equal to VA to find the total flow, the many runners coefficient of the channel is equal to 0.05 for the tall grass cover. After we draw a straight line in the hydrograph, we find the direct flow, which use the base flow minus the total flow. Then the total direct runoff volume is 1131552. Then the runoff depth is total direct runoff volume divided catchment area. We get 2.084 cm. Next, UH ordinate was found by using the formula direct flow divided runoff depth. After calculate all the value, we plot a unique hydrograph. In July, we also use the same method, which is straight line method, to plot the graph. This tree is the hydrograph and unit hydrograph for July. By using the same method in November, we can find the water level, total flow, and UH ordinate in the graph. This tree is the hydrograph and unit graph for November. For the third part of the project, we was find the peak flow of the river with the highest water level. First, we use the rational method to find overland sheet flow path L is equal to 3540 meter, slope of overland surface equal to 3.9%, and Horton's roughness N equal to 0.035, which is poorly grass. The overland sheet flow travel time is equal to 43.5 minutes. The time of concentration is equal to the overland sheet flow travel time, which is 43.5 minutes. Then we change it to hours, which is 0.73 hours. For the peak charge is equal to Tc. The average rainfall intensity I is equal to 94.48 millimeter per hour. Then we find the charge by using the formula. We get the value is 1140.06 meter cube per second. The second method we use to find the discharge is cross-section profile slope area method. The width of the channel is equal to 14.6 meter. By referring to the MASMA second edition, the meaning roughness coefficient N is equal to 0.035 was selected, which is grass drain with short grass. We find the slope by using the Google Earth probe. We get 0.00685. For the area of the channel is equal to 642.4 meters square. The weather perimeter is equal to 102.6 meter. Then we find the hydraulic radius, which is 6.26 meter. Finally, we can find the discharge by substitute all these value into the formula. We get the value is 1631.67 meters cube per second.
Assalamu alaikum, Doctor. My name is Mukhtar. I will present in discussion part. In our research, we delved into the fascinating relationship between rainfall and water levels in Johor, Malaysia. Specifically, in this project, we chose Segamat district, which is located in Johor Bahru. We select three key stations to conduct our investigation. These stations are Sungai Lebis in Kechi Katong, LBP Lebis, and Imbangan Chuase, served as points for vital points for collecting rainfall data. Additionally, we meticulously gather water level information from Sungai or river Lebis in Kechi Katong. We use different methods like arithmetic mean, TS and polygon, and isohedral to estimate rainfall. Each method had pros and cons, or advantages and disadvantages. By comparing the results obtained from the proposed catchment area of the topographic map for each station, we take the rainfall data for 7 consecutive days to do calculation. The mean annual rainfall result is obtained from the three methods are arithmetic mean with 9.19 millimeter, TA symbolic with 10.69 millimeter, and isohedral with 9.42 millimeter. This highlights the distinct approaches estimating rainfall. To find the peak flow in the catchment area, we use two methods: the rational method and river cross-section area method. The result is 1140.06 meter cubic per second for the rational method and 1631.67 meter cubic per second for the cross section. Yeah, that is also show us a little bit difference. That is the discussion, but thank you so much, Doctor.
The conclusion: to sum up, precipitation is an essential part of Earth's hydrological cycle and is vital to the maintenance of ecosystem, agriculture, and human activity. Although rainfall is necessary to sustain life, too much or too little of it can cause a number of problems, such as drought, flood, and soil erosion. Planning for water resources, protecting the environment, and being prepared for disaster all depend on effective management and an understanding of rainfall patterns. It is crucial to address to the ongoing effect of climate change on precipitation pattern in order to maintain resilient and sustainable communities in the face of changing rainfall dynamics.